welcome everybody. Let's do this. Today will be our second lesson on systems of equations, and just to have a brief description and definition here, when you're solving for more than one variable at a time, we create a system of equations. So when you take a look at this equation over here, notice how many variables do you have when you take a look at just this equation over here. Notice that if I have y equals 6x minus 20, we have two variables. We have the x and the y. When you also take a look at this equation, same idea. How many variables do you have? You have two. You have the x and the y. The game plan is, how do you get x by itself and get y by itself? And that's how we want to solve these systems of equations. So here, the general strategy is create an equation with just one variable. Because right now here I have two variables, and here I have two variables. The idea is, can you change these equations around such that you have an equation with just one variable? So the idea is, a little magic trick that you're allowed to do is, that notice that if y is equal to 6x minus 20 and y is equal to negative 4x, notice that this expression is true, that y is equal to y. So all I want to do is, if I know y is equal to y, right, something is equal to the same thing, anywhere I see y, what can I put? I could put either 6x minus 20, or I could put negative 4x. So notice that for this y equals y, I could say 6x minus 20 is equal to negative 4x. Right? Because one of the y's is this 6x minus 20, and the other y is also equal to negative 4x. And notice that if you take a look at just this equation over here, right? Did we accomplish our strategy where we created an equation with just one variable? We did, right? Because this equation has two variables, this has two variables, this has only one variable. So now let's try and solve for just x over here. What I want you to do is pause the video. How would you actually solve for x over here? How would you do it? Right? What would be the first move? You want to get an x on just one side. So what I would do is I would subtract 6x, subtract 6x. Right? So now I have 6x minus 6x cancels. This is negative 20 is equal to negative 4x minus 6x is negative 10x. So now that if I have negative 20 equals negative 10x, what would be the final move to get x by itself? Right? You can divide both sides by negative 10. Right? You want to get this x by itself. So this cancels. And notice that what is negative 20 divided by negative 10? This is positive 2 is equal to x. Or you can say x is equal to 2. Right. Great. So notice that what did we do to actually, let's rewind, what did we actually do? We made y equals y, and we just substituted the value for y. And notice that we had that idea where we created an equation with just one variable. Now, if you know x is 2, how do you find what y is, right? If you know y is equal to 6x minus 20, and y is also equal to negative 4x, what you could do is you could plug this x equals 2 into either this equation, right? You could either put it into the top equation or you could put it into the bottom equation. Let's see what happens. Here, if y is equal to 6x minus 20, everybody pause the video and plug in 2, and what do you get? Right? If I were to plug in 2 in here, notice that y is equal to 6 times 2 minus 20. So y is equal to 6 times 2 is 12 minus 20. Y is equal to, what's 12 minus 20? This is negative 8. Right? Or I could have plugged in where 2 into this equation. Let's see. Do you think you should get the same solution? Or would I get a different solution for y? Let's see. Y is equal to negative 4 times 2. So y is equal to, what is negative 4 times 2? It's negative 8. So notice that it didn't matter which equation I plug the x into, right? This x equals 2, I plugged it into the top or the bottom. Notice I still got -8. If I had to go back in time and choose which equation I would plug 2 into, I'd probably plug it into the bottom one because it was just one easy move, right? Okay. Now here, for this part, to really understand what's going on, notice that for x we got 2, and for y we got -8, right? The question that we really need to just examine very quickly is, what do the solutions represent visually? Like, this has a visual representation. And for you to really understand this, this should give you a hint if you see something like this. Hint. This is in the form of y equals la 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 la, right? This is y equals mx plus b. This is a line, right? This is an equation of a line, and this also is an equation of a line. These two represent lines. So let's just take a look at our calculator very quickly. Take a second, have the calculator next to you. What I want you to do is reset the calculator, right? Second plus 712, right? And let's just examine something very quickly, because here, if I go to y equals, and what I want to do is, let's plug in this equation very quickly, this 6x minus 20. If I plug in 6x minus 20, right? And what's the other one? -4x. Notice what we want to do is we want to see what is the connection between this 2 -8, when x is 2 and y is -8, with these two equations. Well, if I hit graph, notice that this is the blue line, which is the top equation. And then we have the red line, which is the bottom equation. And notice that this line and this line, it looks like they intersect. Where is that point of intersection? Notice it's right now it's not specific. What I could do is if I go zoom, trace, I don't know why it's in Spanish. What happened here? Who put it in Spanish? Primera curva, segunda curva. That's so interesting. I can't believe somebody actually changes Spanish. But notice that the point of intersection is, look at the point of intersection between the two lines. It's 2 -8, which is the solution that we have over here. The solutions represent the point of intersection. Let me write that down. The solution represents the point of intersection for both lines. And this is it. Whoever is the person who changed this to Spanish, please let me know. I have no idea who did it. But okay, take a look and try this one, right? And let's just review. What did we do, right? How did we actually solve this from the beginning? Remember, your strategy, right? Let me, where was the sticky note? Sorry. Okay, I can't find it. Here, what was the strategy? You wanted to get, sorry for pausing. I tried to find the piece of paper, I couldn't find it. Here, remember what your strategy is. You want to create an equation with just one variable. So notice that if y equals y, you just change what this y is to this here, and this y to this here. Now notice that this equation just has one variable, so you are able to solve it. Let's try this one by yourself. Pause the video and try and solve this one by yourself. And when you're done, you could either use your calculator or go to desmos.com to plug it in to see what the solution looks like, right? What do these two lines look like? Right? So let's say if you pause the video and you want to see how it's done, notice that y equals y, right? So you know that this is -6x is equal to -4x plus 6. What I want to do is I want to get x by itself, so I'm going to add 4x. So now I have negative 2x equals 6. Then what do I do? If I have negative 2x equals 6, right? I'm going to, how do I get x by itself? I divide both sides by negative 2. So x is equal to negative 3. Right? That's one of the solutions. X is negative 3. Let's take a look at this one here. Notice that if x is negative 3, I could plug in negative 3 into this equation or this equation. Which equation is easier to plug it into? It's this one, because it's just shorter. But what I'll do is I'll plug it into both so you can see. So y is equal to negative 4x plus 6, right? If I plug in x is negative 3, this is y equals negative 6 times negative 3. So this is y equals 18. And notice I should get the same thing here, right? So y equals negative 4 times negative 3 plus 6. Notice this is y equals negative 4 times negative 3 is positive 12 plus 6, y equals 18. Right? Notice that if x is equal to 3, if x is equal to negative 3 and y is equal to 18, right? If this is my solution, what should happen between these two lines? And how do I know that they're lines? Because they are in this form, right? Y equals mx plus b. What should happen with these two lines? Well, let's see. If I go to Desmos very quickly, or if I go to my calculator, if I type in y equals, what was the first equation? Y equals negative 6x. The other one was negative 4x, negative 4x plus 6, right? If I graph it, oh, it looks like I could already see what's going to happen. Notice they're not going to, you can't see where it intersects because it should intersect at negative 3 and, negative 3 and positive 18 over here. So what I need to do is I need to go to window and let me change my Y max to like 20 or something. And then, you see now I can see more of the top. Notice they intersect right over here. And let me just change the window a little bit more. Y max, let's say 25. And then, this is 1. It's 25. Graph. You see, this should be 1, 2, 3, negative 3, and that's going to be 18 over there, that point over there. And if you want to see for yourself, second trace, intersecciones, whoever did that, second trace, intersection. So this is one part of the graph, this is another part. Notice the approximation, negative 3, positive 18, just like we got here. Okay, what I'd like you to do is try these questions on your own. This was level 1. Level 1 was not too bad. Notice that for level 1, y is by itself. If you take a look over here, for this question, pause the video and copy it down. And also this question over here, x is by itself. So try and solve this equation and this equation by yourself. I'll see you in class.